Today we're going to I'm going to explain how to solve simultaneous equations with a quadratic. So we already learned how to solve simultaneous equations that are linear. So an example, just to revive your memory: x plus 2y equals 7 and 2x minus y equals 3. These are linear because the variables have degree 1. They are called linear equations, and each one is a representation of a line. So each one is an equation of a line. When we are solving the system of two linear equations, it means we are finding the x, the value for the x and the value for the y that will satisfy both equations at the same time. This is algebraically. And graphically, if we plot these two lines, we are going to find the points of intersection between these two lines, which represent also the x and the y that we already found while using the algebraic method. And the x and the value of y, they both satisfy the both equations at the same time. This is why we call it simultaneous equations. Now here we are going to have one quadratic equation, which means that the variables have degree 2, or one of the variables have degree 2, and one linear equation, so the variables have degree 1. So this is why we said that we are solving simultaneous equations with one of them is a quadratic equation. So let us start solving these kind of systems, and keeping in mind that we can only use here, or it's better to use here, the method of substitution. So the substitution method is the best method that we use in order to solve such kind of equations. So we write y equals, so y as a subject of the equation, and we take x to the other side, so it's x plus 3. Now if you're asking, can't we have x equals? Yes, you can have x equals, and you can have x as the subject, and then you would have y minus 3. So the value of x in terms of y is replaced here, and you're solving for y. Or you can find y in terms of x, and then you replace it instead of y in the quadratic equation, or in the equation of degree 2. So either methods will be fine, and you will get the same answer. So here we started with finding the value of y in terms of x, and then we replaced the value of y in terms of x in this equation, where it's x squared plus x plus 3 squared equals 29. So we expand this one. We expand this perfect square. Let me remind you, it's a plus b squared, which is equal to a squared plus 2ab plus b squared. So if we have x plus 3 squared, we are squaring the first, so it's x squared, plus 2 times the first times the second, plus squaring the second. So this is x squared plus 6x plus 9, and this is what we got here. Now we have to solve for x. So combining x squared and x squared, you get 2x squared plus 6x, and you take the 29 to the other side, so it becomes minus 29 plus 9, it's minus 20. Now you've got an equation which is quadratic, which means of degree 2 for x. Therefore we start solving for this x by the methods that we know, which is mainly factorization. So I noticed that I have a greatest common divisor between the numbers, which is 2. So you divide by 2. When you divide by 2, you get x squared plus 3x minus 10 equals 0. Now we factorize this quadratic equation, and factorizing this quadratic equation, we would have x plus 5 times x minus 2. These are the factors which is equal to 0. Their product is equal to 0. Therefore, the factors, either one is going to be equal to 0. So it's x plus 5 equals 0. So x is equal to minus 5, or x minus 2 equals 0. So x is equal to 2. So we have two values for x because it's a quadratic equation of degree 2. After we find the value of x, we replace it in the equation of y. So y is equal to minus 5 plus 3, which is equal to minus 2. And this case here, it's when x is 2, we have y equals 2 plus 3, which is equal to 5. Now, the solutions that we found are two. The first one is minus 5 for x and minus 2 for y. And we have 2 for x in the second value and 5 for y. So these are the two solutions that when you replace them in these two equations, they will satisfy the equations. So let us check this. Let us check what we found. So checking, if 5 was if x, let us take the first one. So we replace minus 5 squared plus minus 2 squared, is it equal to 29? So 25 plus 4 is equal to 29. So it satisfies. Let us check if it satisfies the second equation. y which is minus 2 minus 5, is it equal to 3? So minus 2 plus 5 is equal to 3. Then it satisfies the second equation. Therefore, the points that we found that are the solution for the equation, the two equations, satisfy the equation. Similarly for the values 2, 5.